Hello everyone, welcome back to my channel. I hope you guys are doing amazing. So in today's daily challenge on Leetcode, I will show you three approaches to solve the problem, starting from O of n square to O of n, and then also I will show you two O of n approaches, which will the second one will give you a more optimal solution. Okay, it will also be O of n, but it will be much more optimal. Not much more, but definitely a bit more optimal, and it will also show you some new concepts. So yeah, let's try to solve the problem. So find all k distance indices in an array. You are given a zero index integer array nums and two integers key and k. A k distant index is an index I of the nums for which there exists at least one index j such that I minus j is less than equal to k and nums of j is key. So return all list of k index sorted in increasing order. So the thing which you can do here by a brute force approach will also pass. See, here it is 1000 length. Okay, so it will pass. So if you try to see an n square approach, you have two iterators I and j. So in a nested for loop, you just tell whatever is the condition present here. You just tell whatever is the condition, and you just try to fulfill the condition, and it will work. You just see, I am not doing anything. I'm just doing whatever is asked in the question. Okay, so I will just go through I and j. Okay, I will just go through I and j. So if I go through I and j, I has nothing till n and j has nothing but also till n. Okay, and I am doing exactly what is asked in the question. A k distant index is an index I of nums which for which there exists at least one index j such that this is true. So if this absolute value of I minus j is less than equal to k, if this absolute value of I minus j is less than equal to k, okay, and again I will see that if nums of j is equal to key and nums of j is equal to this key, I will answer dot push back uh, this I. Okay, answer dot push back this I, and once I push back this I want to push back it only once, so I will break out from this while loop. Okay, so from this j loop I will just break out because I want my answer only once. If there are duplicate values, I just don't want it. So if you see this approach, and I can tell you that it will work. It's very simple. I did nothing, but I just followed what they told in the question. There is no intuition or anything involved in this solving it O of n square solution. Okay, so if you try to run this, it will get accepted. Let's try to submit and check. So it's taking some time. So you see, there is memory runtime is quite good because I'm not using any extra memory apart from the answer. But this is 52.84, so it's dubious. Okay, it's dubious, but you can make it better. Definitely, it's O of n square solution. You can try to make it O of n. So how will you do? How will you do O of n? Let's try to see the intuition now. Let's try to see the intuition completely now. Okay, so we need a k distant index. Okay, so let's see this problem. It's given that 349, 139, and 5. So key is 9. You see there are two nines here. There are two keys, and if you go to a key, you can see you are trying to, like, if you go to a key and spread both hands where the hand of your, I mean, your hand length is k. Okay, so 9 is spreading a hand of 1, so it is covering 4 and 1. Okay, so it's spreading a hand both sides, and similarly it's spreading a hand, and this 9 is also spreading hand this. So it covers all the 6 elements from, and it has indices 1 to 6. So you return the indices 1 to 6 here only. Okay. So you try to think it in this way. Okay. So it's very simple, I guess. If you try to just visualize it once more, I will just show you what exactly I am telling. Uh, so let's just see quickly. Let's just go through the intuition quickly. So let me delete this first. And yeah, so we have it. So if you see the you have an end array, you have an array, and you have some key elements present in it. Let's say this has a key element, this has a key element. Okay, these values at these elements are nothing but key. Okay. Now you try to spread a hand, right? A hand of length k. So this is a hand of length k here, and this is another hand of length k. Whichever indices can you cover using this, you just store it somewhere. Okay, you just store it somewhere. You just store it somewhere, and whichever indices you can cover using this k also, you just store it somewhere. Now you might be thinking that I might be exceeding the O of n limit by overlapping cases, right? So you can check that. You might tell me that if this element is, let's say, spreading a hand length of like this, let's say k is like this, it is taking care of these indices, okay, and these indices also. Okay, so you understood, right? Within these elements only, if this is I, this is your I, the indices within J, this J will only be I minus J absolute value. This absolute value will only be less than equal to K if it lies within this region. Okay, so what if this region overlaps? What if this region overlaps? Let's say 0 is now here. The K value is same, so it overlaps, right? So what if it overlaps? Then you can stop this overlapping by making it more optimal. So you can store this thing. I mean, whenever you are doing this, spreading your hands, then what you do, the rightmost value, save it in a pointer. Okay, so let's keep a left pointer, which will be initially 0, and as we will go, we will update it. And what we do, we when we store these elements, first of all, we can use a map. Okay, we can use a maps to store, and the map will have only n elements, so we can use a vector of map also. It will store index, and it will store 1. Okay, the corresponding index, it will store 1 if it's present in the answer. Okay, if it's present in the answer, otherwise it will store 0. So uh, then we can take care of duplicate values also in this way. And you see, whenever this element will be at my, I mean, whenever my rightmost element, I will say that this I minus k, if this is I, right? This will be I minus k, and this is I plus k, okay? This is I plus k. So when I am running a loop to check these indices, okay, when I'm running a loop to check these indices, I can do nothing but this should not be left of this left. Okay, so what I can say is that minimum not maximum of this left value, okay, this left value, and this I minus k, you go from the maximum of this left and I minus k. And when you are going here, you should see that this should not exceed n. So the n should not exceed, but have of minimum of n comma I plus k. So what did you do this? I am not blindly starting from I minus k to I plus k every time. Okay, I'm not blindly starting from I minus k to I plus k every time. I am taking care that which values I have already inserted, which values of indices I have already inserted in my answer. So I will keep a left for that. So that will give me my bound. That will give me my bound. So this bound, we need to start from this bound or I minus k. Okay, we need to start from this bound or I minus k, whichever is the maximum. So you try to see now what I do. What I do is very simple. I check that if nums of I is this value of key, okay, what I do, I start another loop. So whenever I get a key, I start another loop which goes from this I minus k to I plus k, but it will not blindly go, right? First, if I write something like it goes from I minus k to uh, j less than equal to I plus k and j plus plus. If you try to do something, first of all, you will also have a map, right? As I told you. So you will have a map which will be initially initialized with zeros. Okay, so it will be initialized with zeros, and whenever you get this element, it will be initialized with 1. So map of this J, all this map of J is 1, it says that it is lying within the answer. Okay, so whenever you have this, as you have this, I also need a bound integer. Okay, so as I have the left bound with me as 0, so I can do what I can do is that I need to update my left bound also. Okay, but what you can do here, you can put maximum among left and this. Okay, so this ensures that there is no overlapping. This portion ensures that there is no overlapping. I am taking care of the bound which have already been occurred. So you can try to think that this might be I plus k of the previous value. This might be I plus k of the previous value. But as you see, this is n comma I plus k, right? N minus 1 comma I plus k, as you should not exceed the right array also, right? You should not exceed the bounds of the array also. So n minus 1 comma I plus k you should put here also. So this left value is getting updated. I hope you understand this, right? If you cannot understand, you just text me in the comment section, right? But I think you easily understood this, why I am using this left for. As I am going this, I am ensuring that it starts from this. So if you see here, if you try to see here, this is the left. Okay, this is the left and this is the I minus k, which is my maximum. Left is my maximum, so I will start from left instead of starting from I minus k. This will ensure that I have this overlapping region I do not take. Okay, this overlapping region I just do not take it. So it will ensure me that. So that's why I use this left. And this is simple. I use this map also. Now I can go uh, now I can go and store all the elements, right? I can store all the elements in the answer. I can go through the map. Okay, I can just go through the map. So I will ask that if map of I is equals to 1, then you just push back me in the answer, right? Just push back in this map. So yeah, you have it. You have it. You just push back me in the answer. So this will be quite simple. Not pop I just push back the index, right? I need all the indices. So that was it. If I try to run it now, will it work? So you see, we have the accepted. Let's try to submit it and check. Uh, we will have a pretty decent runtime here also. No problem with this. Okay, we have an improved and pretty decent runtime complexity here also. How can I improve it further? So you see, you might think that there are two for loop nested. So how this is O of n? This is O of n because if you see, you try to visualize it in way that each element is either checked for the key, whether it is the key or not, or it is used to insert into the index, right? It is used to insert into my answer. So each index, each element is processed at most twice. So maximum worst runtime complexity can be O of 2n. Okay, O of 2n for this, another O of n for this. Okay, so you have O of n, O of 2n in many cases. You can understand it. So how should I optimize it? We can optimize it further using a difference array. It is not required that much, but I am telling you, we can optimize it using the difference array. So let's see difference array or line sweep array. So if you already don't know this approach, try to understand it as I explained. So you have some vector. Okay, you have some vector. You initialize it as n plus k plus 1 comma 0, and what you will do is very simple. uh, First, I will tell you the intuition. Okay, so you keep line sweep. If you already know this algorithm, I think you can try this on your own also using this line sweep method. Okay, so line sweep algorithm, I have already explained you this algorithm earlier also in one of my videos. So first of all, we have a array which will have all zeros initialized. Okay, it has all zeros initially. And what I will do, I will mark by 1 or -1. So as I find a key, so you see initial array, at some portion I will have some keys, okay, and I need to extend my hands, right? As I told you, I need to extend this k length. So what I will do here is that I will mark this beginning of this. This is forming a complete range, right? I will mark the beginning with +1 and I will mark the end with -1. So what is the use of this? So let's say my key value is something here. Okay. So I will mark this 0 0 array. I will mark this with +1 wherever it is starting, and wherever it is ending. Suppose this is ending at this place, the extra one I will just hop and just mark it -1. So why? Because I am saying that this region I want to take it as that it lies in my answer. Okay, it lies in my answer. So now you see, if you have another element and if it starts with this, it will have a +1 here and a -1 here again. Okay, so between this +1 and -1, if you try to calculate the prefix sum of this whole array, you try to calculate the prefix sum of this whole array, what will you get? You will get nothing but 0 here, you will get 1 here, you will get 1 here, you will get 1 here. Even if something overlaps, you will start getting something overlaps. So if it overlaps, you will start to get something like 2. Okay, but now you are getting 1, and whenever you get this -1, you get the prefix as 0. Then all the way you keep getting 0 until you encounter this +1 encountered by some other key element. Okay, given by some other key element, then again you start getting 1 1 1, and then again you start getting 0. So I only ones and zeros you will get. So you can get twos also. So my point is that whichever element is having 1, you notice that whichever element is having 1, those are the ones which lies in my answer. Whichever elements you are getting greater than 0, the prefix value whichever is greater than 0, those are the ones which lies in my answer. I can directly push back. Now you can see that say that, let's say this element. Okay, let's take a violating case, right? So if I am taking some case, let's say this will be 0 1 1 1 1, keep getting 1, and let's say you will have something here which will overlap. So this will start getting 2 2. Then when this will be -1, again it will give you 1 1 1 1. Then again when this will be -1, it will again give you 0. So you can understand, right? How? But this whole range is positive. So the whole positive range, the positive prefix, this positive prefix, I am putting it into my answer. Okay, because they are the valid region. So how you, I guess you do understand now. So this is +1, this is also +1. So you understand, in our arrays, in our this vector array, what I told you has something like 0 1 0 0 0, again 1, and then after some zeros it will have, not some 0 1 0, it will have a -1, then again it will have a -1. If you try to calculate the prefix of this, I told you it will be nothing but this. Try to calculate the prefix. It's 0, it's 1, then again it's 1 1 1, then it starts getting 2, then it's getting 1, then it's getting 1 again, then it's getting 0. So whichever portion the prefix array will have a positive value, that will be within my answer. Okay, so this is maybe innovative type of concept which you can try to think. Okay, try to think. So what I will do, within my vector array, I will just go and put nothing but I minus k plus plus, nothing else. Vector of I plus k minus minus plus 1. Okay, I have put this k plus 1 to ensure that it doesn't go out of bound, but this can go out of bound, right? I minus k can be less than 0 also. Just check it that if something like vector of I minus k, not vector of I minus k, if I minus k is getting something less than 0, so what you should do is that you should put vector of 0 plus plus only. Else you can put this. Okay, so you are just sort of clipping the value to 0. You're sort of clipping the value to 0. Okay, so you have this, and and nothing else. See, you do not need another for loop inside this for loop. Okay. So if you try to do the previous, if you try to store the prefix value, as I told you, you just put it nothing but okay. So you can just put it prefix plus equals to this vector of I, and you can just see if my prefix is greater than 0. If it's greater than 0, so then you need to push this answer dot. You need to do this answer dot push back I. You just push back the index. So I guess you understood it. I guess you understood it already. So let's try to run it and check. Now, so you see we have the accepted thing. Now if you try to submit it, this is a very optimal case, right? You are just doing O of n here and another O of n here. So sort of O of 2m, but it is definitely optimal than the previous one. You can easily see that it is having 100% beats. Earlier methods were not having that. So it gives a very clean method. It runs in zero runtime. Okay, it runs in just 0 millisecond. So you can understand that this is a way more optimal approach. I hope you understood this also. So yes, that's all. That's all for this problem. This is an easy problem given that it can be solved in O of n square also, very brute force approach. That's why this is an easy problem. And I hope your day is going to be really easy too. Thank you so much.